Hi, welcome to problem 3. A free body diagram of a mass spring damper system is shown below, where x of t is the position of the mass at times t. The system is driven by a forcing function f of t equals to 12 times the cosine of 2t. Okay, so part A says c is equal to 5, k is equal to 4. What is the form of the particular solution? Well, okay, there is one little thing that I am worried about. Let's look at the let's input, so let's do it over here. And that is, okay, maybe the form is 12 cosine of 2t, or like some constant times the cosine of 2t plus another constant times the sine of 2t. However, we have to check to make sure that there is no repetition. And I think in this case, there won't be, because the homogeneous is going to be e to the something. So unless there's like some imaginary, well, let's check. So x double dot plus c, what is c? Well, they tell us it's 5. X dot plus 4x is equal to 0. So we solve the homogeneous. So this is m squared plus 5m plus 4 equals 0. So we can say that m plus 4 times m plus 1 is equal to 0. So m is equal to -4, and m2 is equal to -1. So we say that the complementary solution is going to be equal to e to the -4 times t, c1 plus c2 e to the -t. So here we don't have anything, so we can just say that the form of the particular solution, x of p of t, is going to be equal to a times the cosine of 2t plus b times the sine of 2t, right here. And so I'm going to put right here that the form of the particular solution is a cosine of 2t plus b times the sine of 2t. Okay, now what is the particular solution? Solve for your constants, c0 and c4. Well, let's see, in this case, we want to solve with c0 and c4. So if c is 0, we're not going to have this term over here. So we're just going to have x squared plus kx. So not x squared, x double prime plus k, which is 4. So I'm assuming this is a k, x equals to particular solution. Well, we said 12 times the cosine of 2t was what we had before, right? 12 times the cosine of 2t. Now, if I assume that, assuming x of p of t is equal to what I said before, which is a times the cosine of 2t plus b times the sine of 2t, then what happens is, if once I put it here, what's going to be the first derivative of this? Well, the 2 is going to come out. We're going to have 2a and minus the sine of 2t plus 2b cosine of 2t. Take the derivative once again, and I get minus 2a, well, no, it becomes minus 4. Minus 4a cosine of 2t plus 4b sine of 2t, and actually I need a negative there. So we get a negative here. And now we input this stuff in here. So we input this over here and this over here. Actually, not even. And this over here. And then we match the coefficients and we try to solve. So what I'm gonna do is I'm gonna do this in MATLAB. And so we can even check if this form is the correct form. So we can check two answers with one, video. So I'll see you for part B2, I guess. I'll see you there.